let us resume our discussion regarding the JEE Main lectures or NEET classes lectures regarding the solid state that we have already been discussing. Simultaneously, we are discussing the regular coursework of the solid state also. Our approach here will be solving the problems only, of course. So the regular theories and all you can see from the other videos that I have already uploaded. So based on this concept only we are solving it. It's nothing new. If anything new or new concept comes in between, we will be discussing. But mostly what we know, based on that only the discussion is going on. Today I have chosen such a topic which is obviously advanced level problem, as I have written. It is predicting the formula. Few informations will be given. Based on that, we have to predict the formula of that particular solid under consideration. It will be based on the number of atoms, based on the position that they are in. It may be related to the lattice position, it may be related to the voids. So before we start this video, you may have a revisit to those videos where I have discussed voids and lattice points. So let us start this. So let us choose our first question for today. These are not the regular problems written in the NCERT book, so let me write it down. Then we are going to solve it. The question is, in a square close packing pattern, one atom is in contact with how many atoms in 2D plane base. Options are given as 2, option B is 4, option C is 6, and option D is 8. It's a very easy problem to start with, although it is advanced level and it is also based on the coordination number. So close packing we know, but it is 2D plane. So if it is 2D plane, we are supposed to draw it like this. Two-dimensional square close packing. Square close means this kind of diagram we have to draw. We have discussed this one earlier also. Let us draw another line which will be necessary. Now, so this is the square close packing. You see the manner. These two are touched in this way only, not in the depression, not like this way. It is not like this way. So there is a difference. These and that are not same. Now, let us choose any particular atom in between this. Suppose this one. You check carefully. It is in contact with these 4 atoms, and that is how the square is built up. Right? So what should be the coordination number? This one is in contact with 1, 2, 3 and 4 atoms. So very easy, this answer will be the correct one. And for today goes like this. In a cubic structure of compound which is made from X and Y, where X atoms are present at the corners and Y atoms are at the face center. What will be the molecular formula of the compound? 4 options are given. So for that, first I have drawn the cubic structure. Then you can see with blue I have drawn the X atoms, this one. So X atoms are present at the corners and Y atoms are present at the face center. So Y has been drawn in red. What is the molecular formula of the compound? So to do that, what I have done is, see here, X atoms which is present at the corners. There are 8 corners. I have written number of atom into the volume contribution within cell. So here you see number of atom. There are 8 atoms, and we know for corner atoms its contribution within the unit cell is 1 by 8. So 8 into 1 by 8 gives rise to 1. On the other hand, see, there are 6 face center where the red atoms, Y atoms are there. So there are 6 atoms, but for face center it contributes half of it, because suppose this atom, it is shared by 2 unit cell side by side. So its contribution is half, so it is 3. So X and 3Y. So the formula will be X, Y, 3. In our next question, it goes like this. In a face-centered lattice, X and Y atoms are present, where X atoms are present at the corners and Y atoms at face centers. Then the formula of the compound if one of the X atom is missing from a corner. So the options are given as X7, Y24, option B X24, Y7, option C XY24, option D X24, Y. It is a similar one compared to the previous problem. So let me draw the unit cell once again. So an FCC unit cell. Same question as before. X atoms are present at the corner, so quickly let us draw the X. Here this one I have not drawn because here it is written X atom, one of the X atom is missing from a corner. So I have drawn 1, 2, 3, 4, 5, 6, 7. This one is kept vacant. Y atoms are present at the face centers. So 1, 2, 3, 4, 5, 6. Now let us see the contribution. So for X atoms, there are how many atoms? 7 atoms now. Each contributes 1 by 8. So it is 7 by 8. Here it is 7 because one atom is missing. And for Y, there are 6 atoms, each contributes half, so it is how much? 3. So the formula goes like this. It is X 7 by 8 and Y 3. So obviously, to keep it simple, it should be X7 Y 24. This should be the formula. So this is the first option is supposed to be correct. The next question for today is like this. A solid has a structure in which W atoms, the tungsten atoms, are located at the corners of a cubic lattice. Oxygen atom at the center of the edges. This is a new one, center of the edges, remember. And sodium atom at the center of the cube. The formula for the compound is 4 options are given. So let us draw it very carefully. So a cubic lattice has to be drawn as always. So this is the cubic lattice. Here, first thing first, O atoms, the oxygen atoms are at the center of the edges. So that I will draw last. Sodium atoms at the center of the cube. So sodium atom, this one, is at the center of the cube. So W atoms are located at the corner of a cubic lattice. So W is located at the corner of the cubic lattice. So W is located at the corners. So this one is W. The red one is sodium atom, and this one, which is filled inside this one is, suppose, the oxygen. This was oxygen actually. It is present at the center of the edges. Now see, this is the edge. One atom will be here. This is the edge. The center of the edge means this one. Here one atom. Here another one. Here also. I hope you are getting me. So center of the edges. Here also. All the edges should have one center. There this atom will be present. And these two. I hope I have covered. Sorry, this one is missing. All the edges. See this carefully. Now the contribution. So first for oxygen. First for the corner atoms, which is tungsten. So for tungsten, which is this one, this type of atoms, the 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 atoms. Each contributes 1 by 8. So actual contribution is 1. Next there is sodium atom. Only one atom at the body center, contributes 1 obviously, as we know. Third one is the oxygen atom. It is present at the edge center. Now see how many oxygen atoms are present. there are 12 edges obviously. So on this side 4, on this side 4, and on this side 4. So there are 12 edges, and this one is being shared by 4 unit cell. So its contribution within the unit cell should be 1 by 4. So it is 3. So this is how the contribution will look like. See it carefully. So its formula should be, so NaWO3. This should be the formula.